So we've gone through our covalent notes and started to see how covalent bonds are similar and different to ionic bonds. And you ended with this really great summary. So just a quick recap, right? Covalent bonds are when we have electrons being shared. And this is happening because both electrons or both atoms need electrons to get to that full outer shell. Remember over here with ionic bonds, we saw the electrons transferred because one needed some and one wanted to lose some. So they were giving the electrons away, taking them in, and transferring them, where here in covalent bonds, we're seeing the electrons being shared. And so this is happening then with two or more nonmetals because they have those high amounts of electrons. They need just a few to fill their shells. So when we're thinking about these type of bonds, we've got, again, like a to-do list to work through, again, starting with Lewis dot. And so these first few have an outline for you, again, just like you did in your notes. And then as you get a little further through, they're kind of less formatted, but you're still doing those same steps. So we, of course, need to know our group numbers. So let's get our periodic tables available. Again, you should have your paper copy. But if you don't, you can go halvesies on your notability like I just did. So starting with our two elements, we have nitrogen and iodine. And notice there's a little clue here about how many that you need. So nitrogen is here, group number 5. So I have my nitrogen with 5 outer electrons. Make that a little smaller. 1, 2, 3, 4, 5. I don't know what happens there. Okay. And then iodine. Looking up that one, it's in the same vicinity here. So tracing it up, that is group 7. And I like to really make sure I color code these because that's going to help me differentiate as we go. So I've got 1, 2, 3, 4, 5, 6, 7. So again, looking at them, I should be able to see where those incomplete pairs are. So I have 3 missing from nitrogen and 1 missing from the iodine. So as I start to arrange them here, I always like to start with the one that has the least amount. So I'm going to put my nitrogen right here in the middle. And we kind of think about these, remember, as being like a puzzle piece. So I need to fit in an iodine here in this missing pair, here in this missing pair, and here in this missing pair. So I'm going to set it up with an iodine on this side and putting in my electrons. I've got 1, 2, 3, 4, right? So those are paired up now. 5, 6, 7. So I can redraw and reshift so that my missing pair matches up in the puzzle piece. And I'm going to do that same thing here with an iodine and the same thing here with an iodine. So again, back to my color coding. Starting here, 1 pairs them up, 2, 3, 4, 5, 6, 7. So I've got the 2 on every single side, and then that missing one, puzzle piece fits in to nitrogen. Same thing here. 1, 2, 3, 4, 5, 6, 7. Okay, so I did my first 2, symbol and Lewis dot. I redrew it, showing the shared electrons. And now I need to circle it up, verifying that everybody has what they need. Remember, a full outer shell for most of our electrons are 8. So when I circle, I want to try to include 8 in my circle, showing it has access to everything that it needs. So this iodine, boom, has what it needs. This iodine, boom, has what it needs. This iodine, boom, guess what? Has what it needs. Okay, am I done? Not yet, because I also want to show that my nitrogen has what it needs. So looking at each one of those, all have 8 available to them to create that full outer shell. Great. Last 2 then is we want to draw the bond using the symbols and the sticks or the lines. And remember, what each stick represents is one shared pair. So here, make this a little smaller. Here I have a shared pair, here I have a shared pair, and here I have a shared pair. So I'm simply replacing those shared pairs with a stick. So I'm going to use the same setup. Nitrogen was in the middle. I had an iodine here hooked from a shared pair. I have an iodine here hooked from a shared pair, and an iodine here hooked from a shared pair. So again, that little stick model is just replacing the shared pairs. Finally, the chemical formula will be N, because I have 1 of those, and iodine, 3 of those. So Ni3 is my completed bond. Sweet. Same thing here happening with fluorine. Remember, in a covalent bond, we can bond 2 identical elements. So I have fluorine, 1, 2, 3, 4, 5, 6, 7. And I am still going to switch colors, even though it's the same element. It's a different atom. So that color helps differentiate as we kind of puzzle piece together, right? So again, I want to arrange them here to show sharing. So here's my first fluorine. I'm going to draw it as usual. 1, 2. Or no. Yeah, it's got its 7, but I want to puzzle piece them together. So I'm just rearranging that first one so I can make the second one fit right next to it. 1, 2, 3, 4, shared pair, 5, 6, 7. Okay, show that they're complete with the circles. Again, when I circle, I want to make sure I'm including all 8 in there. There they are. So looking at the shared pair, I replace that with the stick, and I just made F2. Right? So that one was a little simpler because I only had 1-to-1. So once they shared and finished their empty spaces, the bond was complete. I didn't need additional ones. So as you work through, you'll see a couple different elements here. Remember hydrogen, when you're working that one, it has 1 outer electron. It's way over here, right, on the periodic table, 1 outer electron. But remember, it is a non-metal, so it likes to gain. So hydrogen is completed a shared pair by having 1 more, just like we see in the example, and you did with H2O in the notes too. So keep that in mind. It doesn't need, and it will never get a full 8. That's not possible for hydrogen. So as you work through, look for those get starteds to help you with a couple tricky ones, and then keep an eye for a summary get started as needed.